Hello everyone, today our group is going to be presenting about traditions and cultures of Buddhism in Thailand that consist of incense, candles, and combustion that leads to air pollution using Globe Observer. Air pollution is a severe global problem, especially in developing countries. A major air pollutant in urban environments is fine particulate matter, PM1, PM2.5, and PM10, which affects human health negatively. However, the traditional existing air quality monitoring networks are sparsely deployed and lack the measurement density because the installation and maintenance of air quality monitoring instruments are expensive. Low-cost air quality sensors are promising supplements to regulatory monitors for PM1, PM2.5, and PM10. Exposure assessment. Low-cost sensors have been used to collect real-time high-density air pollution data. Low-cost sensors for PM1, PM2.5, and PM10 were developed from the IoT. Investigators can also deploy additional sensors to increase spatial coverage of air quality monitoring network. Moreover, low-cost sensors can gather air quality information of a community in real time at any location. The sensors are potentially easy to use and maintain because they require less energy and space to operate. Low-cost sensors have been proposed to stand alone or as complementary components of existing air quality monitoring regulatory networks, which measure air pollution concentrations. However, previous studies have pointed out the inconsistency between low-cost sensors and high-quality regulatory instruments. Low-cost observations may contain uncertainties, mainly due to aerosol streams, temperature, and high relative humidity. The sensors may also indicate bias, as the models are dependent on location, hydroscopic growth, and a specific range of relative humidity. Each sensor type has a distinct characteristics, and many factors affect GHG scattering, including particle size, shape, composition, and relative humidity. Moreover, the particle number and mass concentrations significantly increase in high relative humidity. The objective of the study is to show how traditions and cultures in Thailand that consist of incense, candles, and combustions affects the air pollution in the temple. Next is our research question. We have set up three questions for this research. The first one is, does the distance from the crematorium have an impact on the amount of PM? The second one is, does the transportation in front of the temple have an impact on the amount of PM? And lastly, does the distance from the ubosat have an impact on the amount of PM? Our group believes that the best answerable way is through the scientific method. It gives accurate information and demonstrable results. The scientific method is also including taking action on the research, constructing the hypothesis, and analyzing the results. These reasons make it very reasonable to find the logical answer through the scientific method. For our research method, it is found from the hypothesis that the information we collected from the first hypothesis, referring to the distance of the crematorium, will be inversely proportional to the rate of fine particle matter corresponding to our hypothesis. The distance of the chapel is directly proportional to the rate of fine dust that doesn't correspond to the hypothesis we have set and the data we have collected from the last hypothesis. That said, the amount of vehicles moving past the temple will be directly proportional to the rate of small particulate matter in the measurement, which doesn't match the hypothesis we set from the beginning. Based on the amount of data recorded by our group, it was found that the amount of data was sufficient to draw conclusions about each hypothesis. Because we collect data from different distances, this makes the data have a wide data range, but when averaged, it will be more accurate.
Types of study inside the temple. Each place have a different amount of pollution, so we chose different spots in the temple to get accurate results. Study sites. The study was conducted at Wat Keo Kau Wararam, Wat Chun Sabai, Wat Sai Thai, วัดถ้ำเสือ วัดผาเจ้าจุฑามาศ วัดพรานุมาตรประชาสาร in Krabi Province, Southern Thailand. For IoT and sensory, The material includes three dumb wires, male, female. It's a wire or terminal that connects between a remote electronic circuit and a panel. One jump wire, female, female. Start with female and end with female. PM2.5 sensor, or you can call it PMS 3003. PMS 3003 using sensors laser scattering theory to be able to get in the air sustained particulate matter concentrations of 0.3 to 10 microns. Node MCU is a low-cost open-source IoT platform. It initially includes firmware that runs on the ESP3266 Wi-Fi. Breadboard, or a protoboard, is a construction base of prototyping electronics. Micro USB. Micro USB is a miniaturized version of Universal Serial Bus, or you can call it USB. Notebook or computer. The device that connects to IoT device and measure PM2.5. The last is Arduino IDE, a program that uses an open source style in which the Arduino IDE acts as an interface between the computer and the Arduino board. For the mirror, step 1, place the node MCU on the breadboard. The rest of instruction assume the front of PM2.5 sensor is facing you. Step 2, connect the jumper wire to PM2.5 sensor. Step 3, the second pin of DST22. You should connect it to D2, D3 on the MCU, CVT or WIN on the MCU. The last pin of the PM2.5 sensor is the, is the ground pin. It should be connected to DNB pin. Step 4. Connect the micro USB to MCU and PM2.5 sensor and connect it to the notebook. Step 5. Open Arduino IDE. Software and set up software serial library. It can be installed by using Arduino Library Manager. And the last one, step 6. We can command the sensor easily by using this code.
And on the data collections, we decide to collect an air quality indexes, which we decide to collect three information, which is PM1, PM2.5, and PM10, readings at three sides of each temple, which other side is Lubosot or chapel, crematory, and temple gates at 0, 10, and 20 meters far away from each side. And on the air quality index, it is sent with an IoT, and we decide to collect the data for 5 minutes per distance on each side. And also, we decide to collect the percentage of cloud cover, cloud type, sky clarity, sky color, and surface conditions using the Global Observer Cloud app. And on the data analysis, um, we decide to test the difference between um, PM1 and PM2.5 levels and the number of cars which pass through the front gates of the temples. Secondly, we will now group the data of each PM levels and the distance from visual activities. Then we decide to calculate the mean of the data for each temple. Lastly, We will now create two sets of graph. The first one is the graph which the relationships between PM's levels and distance to each temple. And secondly, and lastly, it is a graph of relationships between PM's levels and the number of cars which pass through the fronts of the temples of each temples.
In the first result, we compare distance from the Yugosot and the PM values. And in the second result, we compare the distance from the crematory and the PM values. In the third result, we compare the car numbers that transport in front of the temple and the mean PM values. In the fourth result, we compare PM values in front of the temples by the time. And the last result, we can illustrate that PM values of each temple. Uh, Discussion. From the graph, we can see that the assumptions are not based on the collected data. In the hypothesis set, the PM must be directly proportional to the distance. The more the distance from the cover increase, the PM value must also be increased. But there are only two graphs that show the result according to the hypothesis. The error value that comes from the data after seeing the graph is for the Uboso in some temples, candles were lit inside and during the COVID situation. The Uboso was not open to participate in activities. From the graph, we can say that the assumptions are based on the collected data. The hypothesis is that the farther from the sanatorium, the PM value must be inversely proportional to the distance. The greater the distance from the sanatorium, the PM values must be reduced with two graphs showing results that are not the same as the hypothesis. Because the external factors affecting the PM values at the time are the arrangement of incense sticks in front of the graves and having a car to drive through. Conclusion. From our research, it can be concluded that the information we collect on the first hypothesis referring to the distance of the sanatorium will be inversely proportional to the PM values, corresponding to our hypothesis. The distance of the cathode is directly proportional to the PM values, which does not match our hypothesis. The amount of vehicle moving past the temple will be directly proportional to the PM values. In the measure does not match because the number of vehicles passed through the temple does not affect the PM values. Problem. In research work, there may be some assumptions that are not good enough. Therefore, it is some important to make a good assumption. The experiments might have a control over the variables or more accurate experiment device that already have a discrepancy in the device. However, our research may lead to the idea of innovating religious ceremonial device that reduce air pollution. It may be an important information in urban planning in the placement of temples that do not create air pollution to the surrounding places, and the data used for comparisons to other research in the future. In consulting a mentor, there is support and assistance in many aspects, be it equipment or consulting in various research and scientific process. And that's all of it for our presentation. Thank you so much for listening.